I'll start recording. And now I'll share my lecture notes. And this is new topic today. I can see Murshid Jia. Who is Murshid Jia? Please speak, Murshid Jia. Can you hear me? Hello, can you hear me? Nobody speaks. Please speak. Who is coming? I'm talking about Murshid Jia. Who is this horrible man? Hello, hello, hello. May I start the lecture? So let us start my lecture. So I am disturbed. Our students are still coming. I have to admit them. They are late, always late comers. They don't wait for teacher. They should come 5 minutes or 10 minutes before teacher starts. Actual starting time is 12:25. You should be here at 12:15 and system ready.
Okay, sir.
Oh, good. Somebody speaking. You see, I don't like these horrible pictures on your profile. You are a human being. You are bloody students. Bloody students, not normal students. You are shit students. Unfortunately, you don't know what is the culture of education. You don't know what is the etiquette of presenting yourself in front of a professor. So you are changing your name, you are changing your profile pictures, and this is horrible attitude. ये तरबियत का फुकदान है. आपके माँ बाप ने जिस झूले में आपको डाला था वहाँ चुड़ैलें रहती थी. So please correct it. Now you can see on this screen my new topic. Which is general classification of rotodynamic machines. Dynamic machines or rotodynamic machines are defined as when working fluid is in the fans, compressors, turbines, freely passes through the machine over the impellers or blades. They are called rotodynamic. This is combination of two words, rotating and dynamic. Rotating dynamic machines. In chapter 12, we studied rotary vane compressor, which is a positive displacement machine. Rotary vane compressor is not rotodynamic machine. It is because air is sealed between the vanes. It is displaced by the vanes. Now, according to working fluid, we can classify rotodynamic machines as given here. If working fluid is compressible like air, gas, or steam, then machine is called gas turbine or a steam turbine. If it is gas, it is gas turbine. If it is steam, steam turbine. So if it is compressor, then steam compressor or gas compressor. Now, if working fluid is liquid, which is incompressible like water, then machine is called hydraulic turbine or pump. So when water or liquid is pumped, it is called pump and hydraulic turbine. So according to direction of fluid flow, we can classify like this. If the direction of fluid flow is in axial direction, then the machine is called axial turbine, compressor, or fan. If the direction of the fluid flow is in the radial direction, then the machine is called a radial turbine, fan, or compressor, or pump. Now, we can classify also according to the type of blade design. If the blades are designed to change the rate of change of angular momentum of the fluid, then torque is created to rotate the wheels on which the blades are installed. Now, this type of turbine is called impulse turbine. If the blades are designed to increase the velocity of fluid relative to the passages, giving a reactive force on the blade walls, it is called reactive turbine. So, reactive turbine means there is a difference in relative velocity at inlet and outlet, and this difference causes reactive force, and this reactive force causes rotation. That's what's called reaction turbine. Actually, all gas turbines, steam turbines are designed, particularly steam turbines are designed like half impulse and half reaction. Such turbines are called 50% reaction turbines. Now, according to number of stages also, we can define rotodynamic machines. If the energy in the fluid is given to turbine in one row of the blades, then it will be called single stage turbine. In case of very high inlet pressures and temperatures of fluid, this will cause very high speeds of rotating wheel, which will cause high stresses in the blades and ultimately damage the turbine. If the total energy available in the fluid is distributed equally on more than one rows of the blades installed on the same shaft, then the turbine is called multi-stage turbine. This will cause moderate velocity of the wheels and hence safe operation of the turbine. Now, syllabus contents include analysis, design methods, and conventions of turbines, fans and compressors of air, hot gases, and steam. It is included in the syllabus, but we will not discuss hydraulic turbines, we will not discuss hydraulic pumps, we'll discuss only steam and gas turbines and compressors. And to some extent, we will discuss radial turbines also. The objective of this chapter is the students will learn the analysis, design, and methods and conventions of steam and turbines and compressors of axial flow type. So there are special methods and conventions, that means rules or laws or standards, which will be followed, how to start design of blades of steam turbine and how to do the same thing with gas turbine. There is a difference of design between steam turbine and gas turbine because designers have made, with the long experience of 50 to 100 years, they have made standards and conventions and laws according to which we follow how to start design and end the design. The design methodology of steam turbine is different from that of gas turbine. Mostly axial flow machines are covered in detail in this chapter, but radial flow turbines are also touched upon slightly. So this is all about today's lecture, but now I'll share with you another thing. And which is animation. So earlier also I've shown you animation of positive displacement machines. So that is here. GIF, axial compressor, axial flow between blades, axial turbines, and radial pumps. So I'll show you these 4 short videos, and these animations will help you to understand what is rotodynamic machine. You can see carefully, there are light blue color blades, and there are dark color blades which are stationary. Dark color blades are stationary. This is one row of starting from here. This is one row of stationary blades. This is first row of moving blades. This is second row of stationary blades. See this cursor arrowhead. This is second row of stationary blades, and this is third row of moving blades. So this is third row. This is third row of stationary blade. This is third row of moving blades. This is fourth row of stationary blades, and this is last row of moving blades. So this is a turbine. A high pressure, high temperature steam enters here. So these first row stationary blades direct like a nozzle. Their shape in their passage is like a nozzle, and they increase the velocity, further increase the velocity of steam, and they come over these blades, and because of rate of change of momentum, they apply a force, they apply a torque, and because of torque, it starts rotating. So it is designed for 1, 2, 3, 4 stage. So this is a 4-stage axial flow turbine. Flow direction is from axial. Fluid flow is like this. So in the next animation, I will show you axial flow between the blades. How you can see this is the research animation, computerized simulation. This is some researcher has created this simulation. So, sorry, you are not, oh, it's not visible to you, I think. It's not visible. Can you see this? No.
Dr. Lecturer.
No, sir.
No, I did not share it. Okay. First of all, I must
No,
share
sir.
it. Okay, I'm sharing now, right now. There is a...
No, sir.
Okay, wait. I'm sharing now. Now you should be able to see. Can you see?
Yes, sir.
So this is
No, sir.
this is computer animation. Here is stationary blade. This is stationary blade row. This is moving blade row. This is moving blade row. And inside fluid is shown. This is computer simulation. So fluid enters here, then touches with the blade which comes, moving blade which comes in front of this nozzle. This is nozzle. And this blade at the exit direction is changed. And because of this reaction force and because of change of momentum, so this wheel gets force, tangential force, and because of this tangential force, blades are moving. Then this is the next stationary row. This changes the direction of the fluid for next moving row, and like this, fluid flow continues. Now, I will share with you another animation. You can see this is also this is a 2-stage turbine, axial flow turbine. So these are nozzles, these pipes at the inlet. This is axial shaft, and this is first row of moving blades, and this is second row of moving blades. Excuse me. हेलो मैडम, मैं क्लास ले रहा हूँ. हेलो.
चलिए ठीक है सर, आप ले लें क्लास, उसके बाद मैं फोन करती हूँ. ठीक है.
Hello.
Okay. Class is near to finish, and Ms. Rosina wanted to call to me. Hello, let's continue. So you can see how stationary blades in between two moving blades act. They act like a diverter. They change direction of the flow, and they direct when at the exit they direct the flow exactly to the rotating wheels. So this was another way. Now I will show you radial pump. This is a pump, not a turbine. Pump means it pumps liquid, not gas. So similarly, gas also works. Radial flow turbines and radial flow compressors work like this. This is called impeller, a wheel with impeller like this. Impeller has these blades on the disc, and fluid enters from the center, and then this rotating wheel at very high speed imparts mechanical energy to these particles of the fluid, and they are discharged radially at the outlet of this wheel. So are you watching this? Hello?
Yes,
The
sir.
animation in नजर आ रही.
Yes. No, sir.
No, sir. No, sir. No.
Now can you see it?
Yes,
Yes,
sir.
sir.
So this is impeller wheel, a
Yes, sir.
disc with impeller vanes. So impeller vanes draw from the center fluid, and because of high, it's very slow motion. The cycling actually very high, it's 6,000 RPM like this.
Wow.
So when it discharges radially, this fluid, and this is a diffuser. Diffuser means a pipe with changing area. You see, this pipe area starts from here. यहाँ से लेकर ये एरिया इसका इंक्रीज हो रहा है, बड़ा हो रहा है, पाइप का डाया, और यहाँ आके सबसे बड़ा हो गया, सबसे छोटा डाया इधर है. तो ये सारा रेडियली ये फ्लूइड यहाँ से जब हाई स्पीड में कन्वर्ट होता है, इंटर होता है इस नोजल के अंदर. नोजल इज जस्ट लाइक वो जो म्यूजिशियन होते हैं बारात में जो बाराती आते हैं, वो जो म्यूजिक वाले आते हैं, पुलिस वाले, फौज वाले, तो वो उनके पास बहुत बड़ा भोंपू होता है, ये उस शेप का होता है.
बाजा.
This bumpu is like a diffuser. If इसको सीधा करें तो ये एक बहुत बड़ा डिफ्यूजर बनेगा, लंबा सा पाइप, उसको आपने रोटेट करके छोटा कर दिया, तो आपने घर का पंप देखा होगा, उसकी भी शक्ल इस तरह है. तो वो एट द आउटलेट एरिया, उसका इनलेट यहाँ से एरिया डिक्रीज है, मिनिमम है, और यहाँ आउटलेट मैक्सिमम है. दिस इज डिफ्यूजर, मीन्स चेंजिंग एरिया, इंक्रीजिंग एरिया इन द डायरेक्शन ऑफ फ्लो. इट causes kinetic energy converted into pressure energy, and in this way system works. So that is the end. Now I've already sent you my lecture notes of positive displacement machines. You know this. So positive displacement machine. Yeah. So please do read them. Then I will give you today 4 assignments, and these assignments you will do in coming next week within 4 or 5 days, and they are very easy, but you have to be very punctual.
Inshallah, sir.
Inshallah.
No.
And now I want to share one more, which I could not show you last time. One more animation, and that is about positive displacement machine. And in this lecture also,
Yes,
I've mentioned that rotary vane compressor is not a positive displacement machine because of this reason. And now I can share with you. Can you see this? This is a pump, rotary vane.
No,
No,
sir.
sir.
No,
No,
sir.
sir.
Hello.
हाँ जी बोले.
आवाज नहीं आ रही.
Now can you see this?
No, sir.
No, sir. Hello.
No, sir.
No, I've shared my page.
Sir, it's a black
Sir,
screen,
black
sir.
screen.
Black, sir.
Can't
The
be
light
black.
on करें.
Can't be black. Okay, this is a rotating machine, and with this, our time, now time is over.
Oh, sir, nazar nahi aa raha.
Now I've stopped this sharing, and now it's time to go. And check my emails twice a day, today or tomorrow.
Okay, sir.
You know how
Bye,
difficult.
sir.
You know, today's lecture is how difficult for me. I'm wet in perspiration. Light is gone for last 1 hour, and I'm working with my daughter's computer, because in my computer there is no battery. Fortunately, her computer was fully charged, and I could manage this lecture.